Kia ora Year 12, here are questions 9 and hopefully question 10 as well from the school exam this year. So we're going to start with the vector question, which was question 9. We've got two lines, L and M, and we've got these vector equations for them. First thing I'm going to do is to write those into columns, and we have to show that those two lines do not intersect. Right, so this is a classic question that comes up all the time. It's where we're solving three simultaneous equations, and you guys did this really well in the exam. Okay, so let's do that one first, and then we're given information about a couple of points. So P is on L, and we're not told its position vector. We are told the position vector for Q, and then we have to do some stuff with those. But let's just first of all show that they don't intersect. So the first line is R is equal to 2 plus S, negative 1 plus S, and 4 minus S. And the second line has position vector negative 2 minus 2t, 2 plus t, and 1 plus t. Right, so I'm reading that out from here, just taking the coefficients. Right, you could go more slowly if you wanted. In fact, I did. I just didn't put it in here. I don't know why. So usually I would start by doing this. Right, and so I'm going to do that here. There. We might need that later. Okay, so what do we have to do? Well, we have to look at these three equations here and these three equations here. We're going to try and solve two of them and then get values for S and T, and then we show that those values are not consistent or aren't a solution to the equation that we've got left over. So looking at this, you can pick, I know some of you will probably be more awake than me and see smarter ways, but in here, the thing that I notice first up is that looking in here, I've got a plus S and a minus S. So I'm going to work on equations 2 and 3 first. So let's see, we've got negative 1 plus S is equal to 2 plus t, and we'll label that equation 2. We've got 4 take away S is equal to 1 plus t, and we'll label that equation 3. Adding those together, 2 plus 3 gives me 3 is equal to 3 plus 2t, which gives me straight away 2t is equal to 0. So t is equal to 0 from these two equations. What does that give me now? Well, that gives me 4 take away S is equal to 1, so S must be 3. Now, some of you are probably going to go, ugh, those equations look awful because you haven't combined these numbers here, right? And again, I would usually do that, but this time I just dived in and did it like that, and it worked out fine, right? So I'm just trying to show you there are different ways to do these. You don't have to do that cleaning up step first where you get all your S's here, all your T's here, and all your numbers over here. Right, but what we do have to do now is we've got these two values for S and T, and we have to show that they don't satisfy equation 1. So we actually need to do that properly, right? So equation 1 is that 2 plus S is equal to negative 2 minus 2t. So on the left-hand side, we get 2 plus 3, which is equal to 5. And on the right-hand side, we get negative 2 minus 0, which is equal to negative 2, which is not equal to 5. So we need to make it really clear that there's no pair of S and T that satisfy all three equations. And that means that the lines don't intersect. Now, if instead we were trying to show if the lines were parallel, what we'd be focusing on there is just looking at the direction vectors of the lines, right? So that's if we had to do something about whether they were parallel. And if we want to show that two lines are skew, then we first need to show that they don't intersect and that the direction vectors are not parallel, right? So for the intersection part, we're working to try and find a point where they meet. So we're working with the whole line equation, right? But if we're just looking at whether they're parallel, we're looking at the direction vector only. That comes up quite often, and that's sometimes something that people muck up when they're in a hurry. Okay, on to part 2. So given that the line PQ is perpendicular to L, find the position vector of P. So the perpendicular to L bit, we should know that that means we're looking for the scalar product or the dot product to be equal to 0. And that's because we know that the angle between two vectors is this. Okay, and so if they're perpendicular, if this is 90 degrees, the cosine will be 0. But first we need to do some work. We have to find what this line PQ is, and then we'll be looking at it with the direction vector coming out of this line here. So we can't do the dot product thing just yet. So what have we been told? Well, we know that the position vector OQ is equal to 2, 0, negative 1. And we know that the position vector of OP, because it's a point on that line, will be 2 plus S, negative 1 plus S, and 4 take away S. That means that the line that through points P and Q is this. We can find it like this. So it's 2 take away 2 minus S, 0 take away negative 1 minus S, negative 1 take away 4 plus S. Right, be careful with that working. And we get negative S, 1 minus S, negative 5 plus S. Right, what do we have to show again? We have to show that PQ is, where is it? Perpendicular to L. So we know that it's perpendicular to L. We have to find the position vector of P. I'm sorry, that's the dog. That's not me. Right, the dog is snuffling. I think the dog wants to go for a walk. So here, PQ is perpendicular to L. Therefore, negative S times 1 minus S, negative 5 plus S, that gives me negative S plus 1 minus S plus 5 take away S is equal to 0. 6 minus 3S is equal to 2. So S is equal to, 6 minus 3S is equal to 0. I'm getting ahead of myself. S is equal to 2. So now we can take that and we can find the position vector OP by substituting back in. So it's 2 plus 2, negative 1 plus 2, 4 minus 2. Right. So what I'm using back there is this, which was my position vector for OP. But now we know the specific value of S that we need to be working in. So that gives me 4, 1, 2, or we could say 4i plus j plus 2k. So that's that part done. Okay, last bit. Verify that Q lies on M and that PQ is perpendicular to M. So two things to do in there, both of them pretty easy. So we've got the equation for line M. Line M is here. And we've got the position vector here. So what we're trying to do here is to say, well, is there a value of t that makes this fit? And secondly, that PQ is perpendicular to M. So we'll be looking at the direction vector for M and line PQ. All right, first bit. What we need to do, we need to see if the point 2, 0, negative 1 is on this line. And we can see, looking at equation 2, that if t is equal to negative 2, it will work. So now we need to check. If we've got t equals negative 2, what do we have? Negative 2 minus 2 times negative 2, 0, and 1 plus negative 2 gives me 2, 0, negative 1 as required. So that's good. So yes, it is on the line. And then the last one, the direction vector of line M, sorry, we've got dog happenings here, guys. Direction vector of line M is negative 2, 1, 1. And P from P to Q, now that we've got point position vector of Q figured out, so 2, 0, negative 1 minus 4, 1, 2 is equal to negative 2, negative 1, negative 3. Right, so that's my PQ direction vector and my line M direction vector is this one here. So I'm going to do the scalar product and get 4 minus 1 minus 3, which is equal to 0, which is equal to cosine of 90 degrees. Therefore, PQ is perpendicular to line M. Okay, very quickly onto this last question, which is a partial fractions one. So I liked this because you didn't have to actually work out any horrible constants. You just had to show that you understood the appropriate forms for expressing these in partial fractions. And you did well with this one, where there's a repeated factor, but this one not so good. So in order to generate the 4x in here, when we've got a quadratic factor down here and a linear one, we're going to split it up into two. One of them is going to be x plus 4 and the other one's going to be x plus 3. Everyone got that, but what you've missed is that if we're doing that split up, if we just have a constant here, that's going to give me a times x squared. And so what I need to have in this term over here is a linear factor. If I just have a constant here, I'm going to have an unwanted quadratic term stuck in my top line. Okay, so that's the pattern for that one there. That's all done really well, as usual, in Chapter 7 of the textbook. For this one here, we're going to split this up into 3. And we looked at this way back at the start of the year, but when we have that split up, that's the simplest breakdown that we can get to. And that's going to make it very easy to work with those partial fractions and problems where we need to do something with them, like if we need to integrate. Okay, so that's how we do those two. So that really is a memorization exercise. If you've done enough work on the partial fractions, you'll remember those. Now, I think I've just got time to do this very easy last 3-mark question. None of you, I don't think, made the mistake you did earlier in the year of trying to do them by long division, which was a good thing. And that was noted in the examiner's report. These questions are really easy if you remember the factor theorem and the remainder theorem. So we're told that x plus 2 is a factor of p of x. So that means that p of negative 2 is going to equal 0. Negative 2 cubed is negative 8, minus 2a plus b is equal to 0 by the factor theorem. And then by the remainder theorem, we're told that if we divide the polynomial by x minus 3, we get a remainder of 5. So substituting in 3 gives me 27 plus 3a plus b equals 5. So cleaning those two up gives me what? 3a plus b is equal to negative 22. That's from that one there. We should just put in that that's by the remainder theorem. And the first one, I get, what have I got there? Negative 2a plus b is equal to, what have I got? Negative 2a plus b is equal to positive 8. And I'm going to subtract equation 2 from equation 1. Other way around. I'm going to subtract, yeah, that's right. Okay, so 3 minus negative 2a gives me 5a. b minus b goes away. Negative 22 minus 8 gives me negative 30. That gives me a is equal to negative 6. So that's the first one. Chucking that back into there gives me negative 18 plus b is equal to negative 22. So b is equal to negative 4. So that's that. So we finished that question. Very easy 3 marks and really well done by most of you. So good job. I'll be back with the last few questions later on today.